Hello everyone, welcome back. You all in my channel Ramakrishna Math Zone. Today I will start one new thing about series, that is power series. Okay, power series. So what is this power series? Power series means what? Power series means what? A series of the form n equal to 0 to infinity an x minus x0 whole power n is known as a real infinite power series. Real infinite power series. Okay, you got my point? Where an are constants, and we can simplify n equal to 0 to infinity an x minus x0 whole power by n like this. We can simplify this like this: a0 x minus x0 whole power 0 means what, that is 1 plus a1 x minus x0 plus a2 x minus x0 whole square plus dot dot dot. ठीक है, this one is our power series. Okay, some important facts about power series. Some important facts about power series. What are those important facts? First one is every power series converges for x equal to 0. Converges for x equal to 0 for all value of coefficient an. That is what we can say, a power series converges for x equal to 0 for all value of the coefficient an. That is, if power series is not convergent, if power series is not convergent, other than x equal to 0, then the series is called nowhere convergent. Got my point? This simplified form is very understandable for you. ठीक है, fine. If a given series convergent for all values of x, then we can say that the given power series everywhere convergent. The given power series everywhere convergent. Everywhere convergent. Fine. Again, if you try to read this statement, if a given series is convergent for all values of x, we can say that given power series is convergent everywhere. Okay. Given power series everywhere convergent. Fine. Okay. I can provide you one example for you for this B. I can provide. See, n equal to 0 to infinity 1 by n factorial x power n equal to n equal to 0 to infinity un, say. Okay. Okay. Therefore, 1 by r equal to radius of convergence if r be the radius of convergence, therefore limit n tends to infinity un plus 1 by un equal to limit n tends to infinity, ये क्या होगा, x power n plus 1 by n plus 1 factorial n factorial by x power n, that is equal to limit n tends to infinity x by n plus 1, that is equal to 0. That implies r equal to 1 by 0, that is infinity. Okay. From here, what you can say, the minus infinity less than x less than infinity be the interval of convergence. Interval of convergence for given power series. Fine. Given power series. Okay. This one done. From here, what we can say, that is given series is convergent everywhere. देखो, पहले तो मिल गया था कि वो कन्वर्ज करेगा फॉर ऑल आर, तो ऑल आर के लिए कन्वर्ज करेगा मतलब क्या, एवरीवेयर कन्वर्ज करेगा. ठीक है. नेक्स्ट जो कॉन्सेप्ट आएगा वो है रीजियन ऑफ कन्वर्जेंट. नेक्स्ट जो कॉन्सेप्ट आएगा वो है रीजियन ऑफ कन्वर्जेंट. रीजियन ऑफ कन्वर्जेंट. फाइन. ये क्या बोलते हैं, ये आपको बोल रहा है कि इफ द गिवन पावर सीरीज, if the given power series converges for some values of x, try to understood my statement, some values of x, and diverges for other value of x, for other value of x, then set of all values of x, set of all values of x for which it is, the power series is convergent, is known as region of convergent. Region of convergent. Fine. Again, if I repeat, a power series है converges for some values of x, converges. diverges for other values of x. Okay, then the set of all values of x for which it is converges, that is known as region of convergence. Fine. This one important concept, very important concept. Clear? This one is known as region of convergence. Now the concept is, पहले तो मैं रेडियस ऑफ कन्वर्जेंस का फॉर्मूला यूज कर लिया, बट फिर भी you don't know, if you don't know then I will discuss with you. Radius of convergence, ये तो पहले डिस्कस ही नहीं किया, अभी डिस्कस कर देते हैं. तो प्रीवियस वाला जो मैं एग्जाम्पल डिस्कस किया था कि वो एवरीवेयर कन्वर्जेंट है, वो अभी समझ में आ जाएगा. रेडियस ऑफ कन्वर्जेंस क्या बोलते हैं? रेडियस ऑफ कन्वर्जेंस बोल रहा है लेट an x power n is a power series and mod x less than r is the region of convergence, is the region of convergence, ठीक है. then r is called the radius of convergence. Okay, then r is called the radius of convergence. Clear? And radius of convergence you can find by this formula for finding radius of convergence. What that formula is? 1 by r equal to limit n tends to infinity a n plus 1 by a n mod and 1 by r equal to, this was ratio test kind of thing, and this one root test kind of thing. What is this? A n whole power 1 by n. Fine. From these two you can easily calculate what is the radius of convergence. Fine. Okay. From this one you can easily calculate what is the radius of convergence. Okay. Some important results. What are those results? First one, the radius of convergence of x power n is equal to n x power n minus 1. ठीक है. The radius of convergence of this series is equal to this. Okay. The radius of convergence of an x power n is equal to an by n plus 1 x power n plus 1. Okay, these two results are important. Third one, if r be the radius of convergence, of an x power n, then radius of convergence of an x power Pn is r power 1 by p, where p greater than 0. Okay, fine. Now it is fine. Okay. These are the some important results. You need to remember all those things. Okay. Now problem for you, exercise the radius of convergence of the power series, radius of convergence of the power series 1 to infinity n plus 2 by n whole power n square x power n is a square, b 1 by root e, c 1 by e, d 1 by e square. आंसर क्या होगा ना, an is given like this, an is given like this, xn का coefficient, right? This one we can consider like n equal to 1 to infinity an x power n से, ठीक है, we can consider, okay, we can consider this one. Therefore an is n plus 1 by n whole power n square. From here रेडियस ऑफ कॉन्वर्जेंस आर होगा, तो ये फॉर्मूला आपको बोलते हैं लिमिट n टेंड्स टू इंफिनिटी ए एन पावर में 1 बाई एन, दैट इज इंफिनिटी दिस, आई थिंक क्वेश्चन में 2 था, ये 2, तो 1 प्लस 2 बाई एन whole power n, that is n by 2 whole power 2, that is e square. From here r is 1 by e square, that implies our required radius of convergence equal to 1 by e square. आपका आंसर होगा डी ऑप्शन इज द करेक्ट आंसर. समझ में आया? ऐसे इसको सॉल्व किया जा सकता है, ठीक है. Another problem for you, but this one obviously different from first one. Here the question is let an equal to 1 plus minus 1 power n by 2 power n plus 1 plus minus 1 power n by 3 power n. Then the radius of convergence of the power series, radius of convergence of the power series 0 to infinity an x power n about x equal to 0, about x equal to 0 is a1 b2 c3 d4. ये है आपका क्वेश्चन. तो इसको कैसे हैंडल किया जाएगा? वेरी सिंपल. सी here an is this 1 plus minus 1 power n by 2 power n plus 1 plus minus 1 power n by 3 power n. Okay. From here what you can do? If n, from here what we can do? Here two cases are there. If n is odd, what the case? an equal to 2 by 2 power n plus 2 by 3 power n. From here what you can say? 2 by 2 1 by 2 power n plus 1 by 3 power n. ठीक है. Now problem is limit n tends to infinity an plus 1 by an, that is limit n tends to infinity 2 into 1 by 2 power n plus 1 plus 1 by 3 power n plus 1 into by 2 into 1 by 2 power n plus 1 by 3 power n. From here what you can say? From here, if you simplify limit n tends to infinity, then it is basically what? Now 1 by 6 3 power n plus 1 plus 2 power n plus 1 by 3 power n plus 2 power n. From here what you can do? From here you can do limit n tends to infinity 1 by 6, then it is 3 into 3 plus 2 by 3 whole power n into 2 by 3 power n से इसको डिवाइड किया तो 1 plus 2 by 3 whole power n. From here what you can say? From here you can say that this one tends to 0, this one tends to 0, that is basically 3 by 6, that is 1 by 2. From here what you can say? From here you can say r is 2, radius of convergence is 2. Now if n is odd, n is odd, an is what? If n is odd, an is what? 1 minus 1 by 2 plus 1 minus 1 by 3, that is equal to 0. From here what you can say? 1 by r equal to limit n tends to infinity an power 1 by n, that is equal to 0. From here r equal to infinity. Here r1 is 1, here this one you can say like r2, okay. Here r1 is 1, first radius of convergence 1 by r1, okay, and this one. The two different cases are there, even case, odd case. Therefore required radius of convergence equal to minimum of r1 comma r2. From here minimum of 2 comma very large number infinity, that is equal to 2. आंसर आपका क्या हो जाएगा? आंसर आपका हो जाएगा 2, मतलब यहाँ पे क्वेश्चन में दिया था बी ऑप्शन, ठीक है। आंसर आपका हो जाएगा बी ऑप्शन, दैट इज 2, ओके फाइन, ओके। अच्छा, आपके लिए और एक क्वेश्चन में दे सकता हूं। क्वेश्चन बहुत ही इंटरेस्टिंग है, क्वेश्चन बहुत ही इंटरेस्टिंग है। इसको कैसे किया जा सकता है? देखो आपके लिए एक नेक्स्ट क्वेश्चन है कि क्वेश्चन नंबर इज, ओके आई यूज डिफरेंट कलर, लेट an is this 1 by 3 power n 1 by 4 power n if n prime, if n not prime, ये प्राइम होगा तो ठीक है, नॉट प्राइम होगा तो ठीक है, देन द रेडियस ऑफ कॉन्वर्जेंस ऑफ पावर सीरीज an x power n equal to 1 to infinity is, ए बोल रहा है 4, बी बोल रहा है 3, सी बोल रहा है 1 by 3, डी बोल रहा है 1 by 4। ब्यूटीफुल क्वेश्चन। तो इसको कैसे सॉल्व किया जाएगा? सी इफ n प्राइम, देन 1 by r1 radius of convergence is equal to limit n tends to infinity an power में 1 by n, that is equal to 1 by 3. From here R1 is 3. Simple. Acha. If n not prime, this one prime, n not prime. Under this case 1 by R2 equal to limit n tends to infinity a n power 1 by n. From here it is 1 by 4. From here R2 equal to 4. ठीक है, R1 क्या आया था, 3 आया था, ये 4 आया था. Therefore our required radius of convergence क्या होगा, obviously छोटा वाला होगा, minimum of R1 and R2. R1 R2 में से कौन छोटा होगा, R1 तो मेरा 3 था, R2 मेरा 4 था, इनमें से क्या होगा 3. आपका आंसर हो जाएगा 3. ओके, 3 कौन सा ऑप्शन में दिया है, देखो 3B ऑप्शन में दिया है. दिस वन इज योर करेक्ट आंसर. ओके, अच्छा, last I one question for you, and that question is obviously interesting. Question is given that consider the power series, consider the power series (1 to infinity x power n by root n and n equal to 1 to infinity x power n by n. Okay, then both converges to both CGT on convergent on -1, 1. दूसरा बोल रहा है both convergent on -1, 1. C बोल रहा है exactly one of them converges on, exactly one of them converges on -1, 1. None of them convergent CGT on -1, 1. ओके फाइन. सो पहले देख लेते हैं इसको कैसे टैकल किया जाएगा. देखो, समेशन n इक्वल टू 1 to infinity x power n by root n इक्वल टू n इक्वल टू 1 to infinity an x power n से. ओके, हाँ मैं इतना बोल सकते हैं. अच्छा, यहाँ से therefore limit n tends to infinity an plus 1 by an, that is equal to limit n tends to infinity an means 1 by root over n plus 1 by 1 by root over n. From here limit n tends to infinity root over n by root over n plus 1. Clearly it is equal to 1. How? 1 plus 1 by n, that is equal to 1. Okay, अच्छा, ये हो गया. At x equal to 1 this becomes, so for -1 less than x less than 1 it is convergent. Fine, this one we can say. But for x equal to 1 it is 1 by root n, that is divergent. At x equal to -1 by p test हम लिख देते हैं completely. Okay, for x equal to -1 n equal to 1 to infinity -1 power n by root n convergent by Leibniz test. Okay, from here it is convergent on where, now -1, 1. Fine, this one for first one. Okay. Second one, Bn is 1 by n for second one, for second series, second power series. Therefore, limit 1 by r equal to n tends to infinity Bn plus 1 by Bn. From here it is clearly n tends to infinity n by n plus 1, that is 1. From here r is 1, and from here what we can say, see this one also 1 by r equal to, from here r equal to 1. That's why our, in this case also, mod x less than r, that is 1. From here minus 1 less than x less than 1 implies it is convergent. Okay. At x equal to 1, this series become like this, 1 by n, that one divergent by p test, by p test. At x equal to minus 1, this is like this, minus 1 power n by n, this one convergent by Leibniz test, Leibniz test. Okay, this one also fine. Therefore, interval of convergence, that is minus 1 comma 1. For both the case it is given that it is convergent on minus 1 comma 1. तो आपका जो आंसर होगा वो है बी ऑप्शन. Hopefully you enjoy this session. This is, I think, enough for power series. Hopefully you enjoy this session. From this session you can learn everything about power series. Okay. And if you feel that this lecture is helpful for your friends, junior, senior, definitely share with them. Please like, share and subscribe. Thank you.